Dogecoin. Dogecoin. All right. All right, so today we're going to get started on an 820-00239. This is an A1706 model touch bar. So let's just take a look at what this beautiful machine here looks like. You know, it's one that I am kind of interested in all these names that Apple's been using to come up with their devices, particularly since we live in this whole post-Me Too world. You know, they have the A1502 MacBook. It doesn't have a trackpad. It has Force Touch. Force touch. And this one has a touch bar. You know, like you touch the bar. So this is our touch bar machine that may or may not have force touch trackpad. I've been thinking about this for a while. I've been trying to think about who would use the word force touch to describe a trackpad in today's political environment. I just surprised nobody's ever gotten raged on about that on Tumblr. Anyway, so before we get started on this, let's just figure out what the problem is. So according to the label here, it says dead. So we have to figure out why it's dead. Now I can't tell how many amps it's using because I don't have a USB-C current amp meter yet, but I hope to in time. So let's see. It says Linus wants you to fix his iMac Pro that he broke. I don't think I could. I don't think I could find a screen for that. I commented on his video, actually, and it's really sad. We have to tell everybody this, but for a minimum of 2 years after most machines are released, we can't get screens for them. It's lovely. It would be nice if you could, but we can't. It's even worse for the iMac because there's no demand for it since it's very, very rare that the screen breaks, so very few people are willing to do all the silliness in China that has to be done in order for screens to become available to the public. Why are people making fun of Dogecoin? Don't make fun of Dogecoin. It's my favorite coin. It's my preferred cryptocurrency. Anyway. So let me just make sure the chat is stuck out so that I can see it. And we'll get started on this computer. So I have a schematic and a board view open here. Now this is an entirely new design of machine, so let's try and get an idea of how it works. So the first thing is that the charging port, let's just see if I can show you on this camera how the charging port connects into the machine. You don't have a USB meter. I don't have a USB-C amp meter yet. I have a USB amp meter. I don't have a USB-C amp meter. That's something I gotta get. So zoink. All right. So this over here is the charging port, and it connects into the board on this connector. So the first thing I want to do is check out where it is I would expect voltage to be coming in on the machine. So if we look over here, it looks like that's J3300. So we're just going to go over to the schematic and take a look at J3300. You need a broker in China to find it after going to Shenzhen. Only a few people will do that without a fortune. Yeah, that's the thing. It makes sense to pay somebody to do that if it's an item that is very common, like let's say a MacBook Air screen, like the LP133WP1TJAA. I did not get access to those screens until 3 years after the MacBook Air had been introduced. So it took 3 years for me to find that. And when I did, I bought a ridiculous amount of them, of course, but it did take a long time to find them. But it was worth it for that machine because I've bought at least 1,000 of them by now, I'm sure. Okay, so J3300. So that's this. Oh my. Oh boy. All right, so the first thing I'm looking for is power. So this is all USB stuff, complicated USB stuff, blah-de-blah-de-blah. None of that is stuff that I'm really going to be interested in just yet. Okay. Apple refused to fix Linus's no. Yeah, I left a comment on that video. I don't think I'm going to be able to repeat that over and over again in the stream, but I did leave a comment on this video, so you can check that out. Wow, getting asked that question over and over again. Anyway, so here we have PP20V, USB, blah, 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 blah. So that's where I'm going to guess that voltage is coming into the machine. So let's see where I would expect to find that. Ah, this is painful. All right, so I see it at the connector. I see it over here. So that turns into this, and let's search for that. So see, this voltage over here I couldn't find by searching for that. So now I'm just going to search for this, and hopefully that's going to show up somewhere. Here we go. So we have fuses, F3000 and F3001. So let's find those. F3000, F3001. All right, so we have to turn the board over, and it seems like once we turn the board over, we'll see F3000 over here. And when we do that, we should be able to measure it with my multimeter. And by the way, check it out. Multimeter is working on the screen. So we're going to plug this thing in. Plug it in, plug it in. That Glade commercial is stuck in my head from the early 2000s. You'll note that we have this CD3215 chip that's common in the 12-inch Retina is being used here. 0 volts, that doesn't sound right. Hmm, 0 volts. That sounds like an odd number. Really? 0? Let's see if there's any fuses on the other side. Anything that... What about you? I'm curious what's going through that one. All right, so we have 5 volts on this one. Well, what's that one? So let's see. So F3000, which is this, has 0 volts. And this is for PP20V USB-C VA X bus. And that's supposed to come directly from the charge port. But but on the other side of the board, over here, F3001 has power. Interesting. So what's the difference between F3000 and F3001? Huh. Let's see. Okay, I don't understand why. Oh, I guess it's the different ports on the board. So one side of the board has one fuse and another has another. So F3001 would be, maybe that's the way this works? Yeah, because I got 5 volts there, but I don't have 5 volts in F3000. So I'm kind of curious what the difference is between XA and XB. So let's see if we can look that up and try to figure out the difference between XA, XB. Why do we have XA and XB? What is the point here of these two? So we have PP20V USB-C XA, PP20V USB-C XA, and then up here we have PP20V USB-C XB. So why is it on the same connector that we have XA and XB? What's the point of having any... Well, I don't understand that. Can anybody explain to me what the point is of having USB-C XB 20 volts and USB-C XA 20 volts? So it looks like I have the USB-C XB voltage, but not the USB-C XA voltage. Now, I'm going to try and see if there's anything about this design that is similar to other machines. And one thing that you may have remembered from a lot of my older videos is that in order for the SMC to turn on, in order for any of the things to work that deal with charger communication with the laptop, you need PP3V42 to be present. PP3V42_G3 hot is the power rail that needs to be present before every other rail is going to work the way they're supposed to. And what we realized in the 12-inch Retina in the 12-inch Retina, PP3V3, R3V0, or R3VO, whatever it is. That was the rail that had to be present before all the other rails. So that kind of replaced PP3V4 too. And I want to see if the same thing is true for this, because I want to get a hierarchy of what it is I should worry about. Should I worry about the difference between XA and XB before I worry about something else? And I think I may be correct that the answer is no, but there's only one way to look at that going forward. So let's take a look back in the schematic, and it seems like Jessa Jones from iPad Rehab is here to troll. I feel bad. She had a bunch of her time wasted yesterday by a bunch of franchise. Well, I made a promise in my last video, and we're gonna see if I can stick to it. But yeah, poor Jessa. Jessa gets the crap end of everybody's stuff. Why do you think they use 3.42 as a standard, just as versus just the standard 3.3 line? I don't understand. I don't get why they would have done that. Very silly. So let's see if there's anything similar to that here. Let's see, PP3V3. And let's see if we could find anything that's similar to PP3V4 too. Let's see if there's a pattern that presents itself somewhere. So I'm going to see if there's a rail on here that's similar to PP3V4 too on the older machines, because that would be cool and help us get started. Mm-hmm. USB-C has two sides, A and B, so it can be flipped. Well, that explains that. That makes sense. Thank you for the useful info. You can be a mod. Okay. Come on. Find me what I'm looking for. I bet there's going to be something on here that looks very similar to PP3V4 too. Wait, it's just going to take me a minute to find it. Hey, what's this? This is interesting. This here is particularly interesting. So let's take a look at this. So, this looks very similar to some of the old machines now, doesn't it? This rail is going to come on before all the others because it has two inputs. It can have input from PP bus G3 hot, which can be the battery, or if the battery is dead, it can get power from PP DC and G3 hot, which is the charger. When I say that, this is the input on the left side. So this looks very similar to the PP3V42 circuit, does it not? We got the same standard diode that we've had before. We have input from either the battery or the charger. It's the only rail in the computer, the only rail that can have an input of battery or charger. And if we were to open any other MacBook, you would see this very similar pattern. U6990. This is a 2012 non-Retina machine. And you can see PP3V42. We have input from either battery, PP bus G3 hot, or charger, PP18V5. And that turns into PP3V42. Here we have that same thing. And what this tells me is that this rail has to be on before any other rail. The reason I know that that rail has to be on before any other rail is because it's the only rail on the machine that will be powered by either the charger or the battery. It's so important that if the battery is dead, it needs to be powered off of the charger. It's so important that if the charger is not there, it needs to be powered off of the battery. It's the only rail that needs to be powered. It's the only rail that's going to be on from two sources. Now, if we are to look through and see what's going on with that rail, we may get a hint as to what's causing this to be dead, which is what is coming up next. So let's take a look at PP3V3 underscore G3 hot underscore reg underscore R for Rossman. So let's find that. Well, where do we find that rail? PP3V3 underscore G3H. And what do you know? We've got it right here. And let's see what's going on with that rail. So we can find it over here. So we got to find that section. And that's going to be under this little mess. But not to worry. Video quality in the microscope isn't as good as it usually is. That's odd. We'll have to look at that later. Odd. Dogecoin. Did you recently get a MacBook in for repair that was previously at CPR? The customer called us and said you couldn't fix it. I have no idea because I don't have my ticketing system open, and look, I don't think I can look up tickets with 300 to 600 people watching a video because that would be incredibly boring to the viewers. But you are more than welcome to email our customer service email where somebody who's not in a microscope will respond to you during open hours. All right, so it looks like we have 11.6 millivolts there, which is absolutely nothing. Let's see. So we have to figure out why that is. Maybe there's a short circuit of ground. Let's see. I have a liquid damaged MacBook Air, no green light. Battery runs normally, battery in, low bat logo. Any suggestions? My suggestion is that you watch the videos in this channel that I've made, which are at least 15 or 30 of them on no green light, and start troubleshooting accordingly. We have an entire thing called No Green Light on Charger. It's a video playlist that's already been organized, and if you go through that playlist, you will find out, at the very least, where to start looking. But yeah, I'm fixing my board right now. I can't fix your board and mine at the same time. So it looks like we have a 1 ohm short to ground in resistance mode. I think that we have found the cause of our problem. Have we, Pepe?
Yes, I think you found the cause to your problem.
Did we, Pepe?
Inject voltage.
No, we have a thermal camera. We're not supposed to inject voltage. That's what everybody on the internet says I'm not supposed to do.
But people on the internet are dumb.
Granted, I understand, Pepe. I understand that a lot of people on the internet are dumb. But somebody on the internet sent me you. Ow! Bastard. All right, so thermal camera or inject voltage? Which should we do to try and figure out why that shorted to ground? What the hell? We might as well start with the thermal camera. Before we get started with the thermal camera, I'll read the chat and see if there's anything in here worthwhile. And then we can go on to the thermal camera. I see that one person has spammed their question. Well, that is... I genuinely wish you the best of luck in solving your problem. Unfortunately, I have no tolerance for spam in the chat since I'm the only one reading it, so... I really hope you solve it, Mr. Milch. I do. I mean that from the bottom of my heart, but bye-bye. Bye-bye. I hate copy and paste in my chat. I answer questions when I can. Let's see. The A1702 is a pain to repair. Anything Apple that has a model number A17 something is a pain to repair. Did anybody rehot any PMICs? If not, this should be easy. I don't see any rehotting, Jessa, so perhaps this will be simple. How do you decide which jobs get streamed to the rest of us? I flip a coin, or I let Pepe decide. Hey, Nitrocaster. How's it going? Nitrocaster sent me Pepe. Inject the voltage, somebody says. Inject voltage, somebody says. Everybody wants to inject voltage. I would like to find an affordable thermal cam with decent quality. Well, good luck with that one. Would you spend $3,000 for a thermal camera that actually allows you to see tiny components heating up? $3,000 for something that does the job? Maybe I would, but it would have to have zoom. The fact that this doesn't have zoom is completely, utterly unacceptable at $900. But seeing as it arrived for considerably less than that, for the low, low price of free, I will use it. And you can find this thing on what's the website? You can find it on unionrepair.com. If any of you are interested in spending this much money on a thermal camera, you will find it on their website. So let's open up this beautiful application that always opens in a foreign language with no labeling and get started there. So I'm going to put the thermal cam on, Turn off the PDF reader. Make sure that we're reading our thermal camera. Here we go. Here we go, man. All right, we're going to plug this thing in and see if we get any results. This will be fun. I really have to find a place for this. Paul ran the wire somewhere where it's always like smacking me in the face. All right. Gee, come on. Actually, let me find something, a little table or something to put in the middle of the office. Folding chair. Here we go. Now I can put this thing down where it should be. All right. Here we go. This is a perfect spot for this little pile of joy. Okay. Let's see, so we're gonna. Yeah, I really got to put this wire somewhere else. Yeah. This uses Cat 5. It's it's an IP camera. So we did not exactly run the wire in the nicest of ways. All right, that'll do. So now we have to plug it in. So the board right now is not plugged in. So we're going to plug you in. Now the first thing, before we get started, is assessing what the current temperature is. So all these yellow spots that you see here are actually only 29 Celsius. What could possibly rhyme with L2? Says zero effect. What could rhyme with L2? Long screw. Like the repairs that Jessa does every day. Long screw damage. When you put the wrong screw in the wrong hole. That could rhyme with L2. All right, so we've plugged it in. It's plugged in now. And we're going to see if anything gets warm. Anything is shorted here. And there's this little button over here, 1 key leak, that's going to show us. So it seems like this little connector over here gets warm. Doesn't really feel that warm though. That is the jumper. That is the jumper for the SSD. So do keep in mind that if you buy any one of these newer Apple products, that the solid-state drive is soldered directly onto the motherboard. And if you have an issue with your board like this, and you have only backed up your data 1 day or 2 days or 6 hours ago, but you've done any new work, that any of that data is pretty much gone if the board is not repairable. So let's just take off that jumper. And we're going to see if anything here is bad. We got to slide the thing around. We're going to slide the thing around. And see if anything is warm here. So let's see, what's this thing? That's only 2 degrees higher. I don't get, no, that's a coil. That's not going to be it. Yeah, none of this stuff is it. I'm going to keep sliding it around. My teacher has a 2012 MacBook Pro that works, but if you switch to the dedicated graphics chip, it shows strange colors. How much would it be for the repair if we ship it from Italy? Well, the first thing is whether or not it's fixable. Is this the Retina model or the non-Retina model? Because if it's the Retina model, you can typically fix that by a reflow of the U8900 area, which I've done many times. If it's a non-Retina model, tap U9600 and see if that fixes it. If it is a non-Retina model, then that. How much better is the 2012 MacBook Pro unibody compared to the early 2011? They are considerably better, but the issue is, even though they are better, it's still a 6-year-old machine that has bad cooling. So since it's a 6-year-old machine with bad cooling, you can expect that the GPU is likely going to fail again on it. Where did I put my bottle of water? Oh, that makes me sad. I lost my bottle of water. But yeah, I wouldn't buy it just because it's a 6-year-old device that's not cooled well with a very powerful GPU. So even if there isn't a defect with them, it will still wind up failing. In terms of cost from Italy, it's usually 200 to 400 for the board repairs, but you'd be paying for shipping both ways, which is very expensive. So I'd recommend finding somebody in Europe, like Duke, maybe. Find someone from Duke. Okay, so back to this. We have to fix this. We have to figure out where this short circuit is. Where is this circuit? Is it the one you see? Hey, Chris Long, I haven't seen you in a while. I hope everything's going well with you. Wish you the best of business. You all should check out Chris Long's channel, by the way, if you want more board repair stuff. He has a store, I believe, and he does videos on a regular basis, and they're pretty good. All right, so we have this thing heating up here. Let's take a look at what that thing in the middle is. That's the Wi-Fi chip, and that's interesting. It's 30 Celsius, while everything else around it is 26 Celsius. And that's a Wi-Fi chip, I believe. Is that? No, that's not the Wi-Fi chip. I'm being an idiot. All right, that's that on the other side. That would be the Wi-Fi chip. Ignore me. All right, so let's take a look and see what that thing is. So that is on the other side. That is in this section. U3830, U3820. Am I looking at the right thing? Huh? Let's see. Visible light. Yeah, so this is what I'm looking at. I'm trying to find this over here. So let's see if I go to my board view software. Yeah, because this is the row of caps. See? You have that row of caps. And on the upper right, that's the row of caps on the upper right. And then there's 3 caps here, this chip, and then there's this stuff, which is covered. So U3810, U3820, U3830. So what are those things? What do they do? Let's take a look at the schematic. Do you think the recent Apple throttling fiasco will start a trend for some Android manufacturers to slowly bring back removable batteries on their flagship? The glass sandwich market space is extremely crowded right now. I actually think the opposite is going to happen. Here's the thing. Every time Apple does something bad and gets away with it, Android manufacturers, particularly Samsung, start to do the same thing. Samsung was cool because you had a user-removable battery, liquid resistance, and user-removable battery, liquid resistance, and an SD card slot. And then with the S6, they took away the liquid resistance of the S5. They took away the battery that was removable from the S5. And they took away the SD card slot from the S5. And nobody seemed to care. They all seemed to just buy it in droves. So, and then you have this issue with, what are the other issues that wind up happening? Or like, we're not replacing them when or not giving any after sale support for the battery failing. Apple did that for a long time. I mean, they replaced the battery now for $29. They used to replace it for $79. But for the longest period of time, they didn't replace it at all. And, oh, God, they're coming too fast. I got to find that question now and dig it out. But the thing is that they don't... Oh, where am I? Yeah, I got to find that. Anyway, so the issue is that every time Apple gets away with something, it sends a message to every other company that we can do that too. And, you know, just look at Motorola. The Moto G 3rd generation was liquid resistant. The Moto G 4th generation and 5th generation were less liquid resistant. And that is that's what they do. They get away with it. And when the thing is, all these companies, what they think is that, well, Apple's successful and Apple doesn't have an SD card, so that must mean that we need to remove the SD card slot in our phone, and we too will have the cult following Apple has. What they don't realize is that Apple has their cult following due to their usability and marketing and intuitiveness. They have that cult following in spite of, not because of, things like slowing down and non-user removable batteries and no SD card slots and no liquid resistance. They didn't build their business on that. They built it in spite of it. Let's see. Don't know. Let's see. I have a Cohen Z2 that doesn't work. How much estimate to fix it? Oh, God, no. I had a Cohen A2. Let me see if I can find my damn water bottle while I'm talking. I had a Cohen A2 portable media player back in 2005, and I remember using that thing to listen to watch 24 in high school, because I mean, what else are you going to do in your high school classes besides watch television? It's not like there's anything worth learning there, especially in a public school in New York. I found my water bottle. So I used to have that thing, and I remember the headphone jack breaking and opening that, and I mean, finding parts to one-off stuff like that is almost impossible. But they were no fun to open. They definitely weren't any fun to fix. Yeah, I had the X5, the A2, and then at some point I had the Cohen O2. But this is dating back really long time ago. Like when I got a BlackBerry 9530, I stopped using the Cohen separately. Those are the days where I had a separate music player and video player from my cell phone. Wow, I feel old. Times have changed. Let's see, a Steinberg UR44. The SM7B is definitely a good microphone for YouTube. I have no idea about the Steinberg audio interface. I didn't even know that they made audio interfaces. Yeah, no idea. But SM7 is a good choice. Water bottle is sitting under your second monitor. Oh, that's Jason's water bottle, I believe. Throat muscle sounds creep me out. Well, enjoy being creeped out then. So we have a short circuit to find, don't we? So let's get back to that. So so we have to figure out firstly what those components do. Oh, I'm getting so too off topic. U3820. So what is this thing? This is a V-Core multiplexer. Core 1 multiplexer for Wi-Fi and Bluetooth. Well, I don't see any PP3V3 over there. Okay, so let's take a little quick look over the rest of the board before we start injecting voltage into that power rail. Why did Tim Cook cross the road to get to Lewis's store, someone says. How many amps being drawn? I have no idea. I don't have a USB amp meter over here. At least the USB 3 amp meter. So if we were to follow around the rest of the board... Hey, look, that part actually isn't even getting hot anymore. Well, not that hot. 30. Oh, yeah, never mind. It didn't hit the button. Even now, that's not getting really warm anymore. All right, so it seems like I'm not going to find anything here. SOB doesn't even want to give me an estimate. Who doesn't want to give you an estimate? Let's search for your name. Okay. What's up, buddy? Huh. All I see from you is what's up, buddy. About this Zcoin Z2. Oh, I mean, well, how the hell would I give you an estimate? It says it doesn't work. Really? I have a car. My car doesn't work. How much to fix it? What's wrong with your car? I mean, yeah. I don't work on Cohens in general. Just no. But even if I did work on Cohens, how much to fix something that's broken? What's wrong with it? You got to give me something to work with. Jeez. I mean, granted, I still can't answer the question. I still couldn't answer the question because I don't work on them at all. But if I did work on them, I would have no idea how to answer your question, since unfortunately I don't have any idea what's wrong with it. All right, so it's clear that I'm not going to find anything through this method. So what I'm going to have to do is inject voltage. So the first thing to do before we get started with my power supply is make sure it's not set to 18 volts. That would really, really ruin the day. Do you recommend a 2013 Retina? Failure rate. A 13-inch one, sure, why not? 15-inch one, no. All right, so let's set output voltage. We're going to start at 1 volt. And the current, we're not going to have any current limiting because we're only starting at 1 volt. And let's get some wiring here. Do you recommend the 2013? Oh, yeah, that was the one that I answered. I mean, if you really want a MacBook, sure. If you really want a MacBook, sure. The 13-inch, not the 15-inch. 15-inch 2013, terrible. You had that U8900 GPU issue. And the best part is Apple actually made a machine that year, the one with the A203662 board, that doesn't have a GPU. And it still randomly crashes. It's hilarious. It doesn't have a GPU, and it actually has more issues than the one from that year that does have a GPU. Duke and I have still not solved it. If you go over to the forum for the 820-3662, you'll see that none of us have actually solved it. Anyway, so what we have to do now is find out where PP3V3, that rail that is shorted, is on the board, and we're going to inject voltage using these wires here. So let's inject some voltage. That's the first thing I got to do is find where that point was again. So the point that was short-circuited is PP3V3_G3 hot. So what I'm going to do here is I'm going to take a volt from the power supply and send it into the board. And whichever component is shorting to ground is going to get really, really hot, and we should be able to locate it and remove it. And once we do that, God willing, it actually works. So the first thing I got to do is find a space that's better to solder this to. Because if I solder this over here, and this is over there, that's no good, because this can likely touch that. That would be very bad. So I want to find a space that I want to have some more room to work with. I want to connect it to something that is convenient. So let's see if I can find a space that's convenient. What I'm looking for is some large component that's separated from other components nearby. That would be preferable for me. But it doesn't seem like I'm going to get what I want. Well. All right. What's the next best thing? I suppose I could connect it to this. Yeah, R6915, pin 2. Let's see, where are you? Oh yeah, this is fine. So what I'm gonna do is I'm gonna connect the wire right here, and then the ground can go right down under it. Chris Long says, I feel like I'm talking to a chair. Yeah, I need to get one of these days I'll have a real streaming setup. This office is really too small to arrange the camera in a space that would make sense for this. Okay. So. What about iFixit's lifetime warranty on logic boards? Well, what about? I think it's great that they have a lifetime warranty on motherboards, but at the same time, I would not suggest that you buy a replacement board for a device that has serious issues. You know, I would not buy an 820-2915 from iFixit, not because I don't trust iFixit. I'm sure they're going to be nice people and they're going to happily deal with you and have a nice customer service department, and, you know, all the people on their YouTube video streams seem nice and lovely and like they're not going to mess with you if you have a problem, but it's just you're going to have a problem. So if you're looking at something like the 820-2915, just stop, don't pass go. You know, if you buy a Lemon, if you buy a Ford Pinto, it doesn't really matter which dealership you get it from, you know? That's not... I'm guessing Pure Diagnostics isn't a service you offer. I offer free estimates. I don't offer diagnostics because diagnosis means find out every single little thing that could potentially be wrong, exactly what it is, and that's just not worth it. That takes way too much time. And also, it can't be offered on every device because I don't have parts for every device. So, remember with the MacBook Air what I said? It took me 3 years to find screens for that machine. 3 years. It's only worth it to go through that effort. The thing is, we're dealing with manufacturers that don't offer us any support. So it's only worth it to do this work on these products if we are going to get tons of them. So if I know that there are thousands upon thousands upon thousands of people that are going to walk in with the same problem every day, it is worth it for me to sit here for 8 or 10 hours a day messaging a bunch of people for months and months on end, and then sending money, and then getting parts, and then realizing they don't work and I wasted money, and then messaging somebody else and paying them money for parts, and then getting parts and realizing they don't work, throwing them out, then trying again. It's worth all that gambling for a device that I'm going to be working on 10 times a day. It is not worth doing that for a device that I'm going to see once or twice. Now, if Cohen were the type of company where they said, oh, hey, here's a service manual. Oh, hey, here's all the parts that you can buy at a good price that are guaranteed to be OEM and not stuff that was just tossed out of a dumpster. And if it doesn't work, we'll replace it rather than force you to wire money to some random person in China that if the parts don't work isn't going to help you. If that ecosystem existed, it would totally make sense for us to do diagnostics on all these different devices. But it doesn't. I mean, just finding this machine over here. This board came out in 2016. I did not have a schematic for this until about a month ago. It took a year. It took a year, something like 14 months to get a schematic for this. You know, it's not the type. This is not the type of business where one-off repairs often make sense. And I'm not saying they're impossible to do. Some of them you could probably guess. Sometimes you can find a part on eBay and it's great. Sometimes you find a part on eBay and it's absolute garbage because the good parts are unavailable. And then the customer hates you because you did a crappy repair, or the customer hates you because you took too long, and, you know, it is what it is. So, anyway, let's go back to this and see what gets warm. So I'm going to start injecting a volt in, and at 1 volt, I have 0.5 amps. So 1 volt, 0.5 amps, that means that I'm putting half a watt into this board, which means something should be getting warm. Now, I'm going to try and drag this thermal camera over here, which means going through the maze behind Paul's desk of extension cords to unplug it and plug it into my desk. And, Jesus. There we go. Okay. And we're going to check and see if this thermal camera can find out what's getting warm. It would be really cool if it actually could. I have my doubts, but if it could, that would be cool. So let's plug this thing in. You would play our Lavery Blue A. Well, Lavery is one of those companies where I think they should do the repair for you. I mean, they're a very high-end company. You probably spend $5,000 or $10,000 on that DAC. They're well known in the community. I don't think they're the type of company. They're the opposite of Apple. I don't think they're going to do the type of stuff that Apple does or standard consumer electronics companies do. At least not with the niche community that they deal with. Is there any 15-inch MacBook Pro with GPU without problems? Geez. The 2009 model with the MCP79, those never died. Okay, where am I going to put this cable so that it stops hitting me? Let's see. What if I put it around the light switch? Yeah, there we go. That's totally not. That's totally not. Ghetto? I'm behind on messages by, let's see, how much? 6:17 at 6:25, so 8 minutes. Do you need a MacBook repair? Why not do it yourself? There's a Bitcoin miner doing. No dice on that so far. You seem to not fully understand how infrared cameras work. Metal of any kind is a mirror. Yep, I definitely don't understand how they work fully because I've been using alcohol to find my shorts for the past few years. Okay, so let's put this under this. You can see what my desk looks like. Or not. Hello. Nothing works at this office. For all the time we put into making other people's stuff work, I gotta say, nothing of ours ever works at this office. All right, so this is the camera, and I can't help it. It's funny. It's funny. We're gonna put the thermal camera on screen so that you can see. So we got the power supply dishing out voltage, and thermal cam is next. So here, thermal cam. Oh, well, you're plugged in. Oh, you're not plugged in. You know what? That would be really smart if I plugged it in. I bet it would work a lot better. I bet this would work much better. Yes, turn on. You can do it. Can you replace the hard drive in these? No. The SSD is soldered on the board. Hey, how did I just... Why did you invert? Don't invert on me. Get a selfie stick attached to your chair. I'm sure my NEX EA50 will be happy on that. Best laptop with least need for repair or durability. I have a Lenovo P50. I think it's pretty good. What's this? What's this? What's this hotspot? Let's take a look. Is that for real? Let's turn this the right way so that it's not gonna... Let's turn our volts up a little bit. Hmm. 1.7 volts. We've got a show. Got some fireworks here. We'll take a look at what that area is for in a moment. What's the latest on MacBook repairs for schools? Have you secured any contracts? Nope, they're still going to franchises that heat gun the CPU, probably. Wow. Such heat. Much short. Dogecoin. Such fireplace. Now, what would be really nice at this point would be the ability to zoom in and get an idea of which component is actually causing that short. It would be nice to zoom in, but I don't think you get to do that. I'm guessing it's going to be something over here. So let's turn back to the visible light. So something over here. Back to infrared. This thing at the end. Whatever this thing is. The 2013 MacBooks, for example, do not suffer from GPU overheating. You hear about the few that did fail, not the thousands that didn't fail. No, they don't suffer from GPU overheating. They suffer from U8900 becoming desoldered from the board, which is a totally different issue. And you do hear about the thousands that don't fail every single day. Let's see. So interesting. Much repair, says Nitrocaster. What if you just lift the board closer to the camera? It's hard to hold it without it being unsteady. I suppose you could do that with, you could put like a little something on it, but you can tell the camera quality is just such junk when you go up to it. It loses all ability to focus. It's designed to focus at this level. So this is the point where the $900 tool has given me the area of the board that I should focus on, but once again, the 20 cents worth of alcohol will tell me what's actually going on. Because my microscope can do things like zoom and focus. Now, I'm kind of curious if any of you can tell me what you think is causing this issue. Take a look over there and tell me if anything looks obviously messed up to you. What do you all think? What do you all think? Much corrosion. All right, check this out. Now, we're on the board view software. Which one of these components has a connection to PP3V3, and which one of them has a path to ground? Do you see any components that are along the PP3V3 line in the board view software? What do you say? I don't even need alcohol for this one, honestly. Dogecoin. The ugly cap. Chris Long is correct. So we can do this. And it looks like Apple is now using underfill in these boards. Look, check that out. Just knock that little bugger off. And it looks like we no longer have a short, because at 1.7 volts we're putting out 0 amps, where before we were putting out more. So we knocked that capacitor off of the board, and now I'm kind of curious if we get PP3V3 back. So it looks like the issue was C3200. Now let's take a look and see what C3200 is for. C3200 is let's see, this should be here, the smoothing cap or a decoupling cap, right by where PP3V3 underscore G3 hot enters U3200 to ensure that U3200, which is very important. This is where all the USB-C controls are. This is where this chip talks to the USB-C charger, and it controls all the muxing and all that kind of stuff. So this chip is not going to get power, and this chip is very important. It needs to get power so that it can talk to our charger, so that the charger can do what it's supposed to do. So you'll see that this has a lot of connections. Yeah, let's see. See? Let's find out where this has connections to the charging port. Let's see. USB-C port controller. USB-C XB CCC1. Where do you go? Yeah, see? So that goes straight to J3300, which is the USB-C connector. There are many data lines existing between U3200 and the charge port. So if this chip doesn't have PP3V3, it's not going to turn on. And if U3200 doesn't turn on, the charger is never going to be able to talk to the computer. It's never going to be able to negotiate the 20 volts that it needs to actually do stuff and work, which is why nothing is working. And that's why we're getting 5 volts out of the charger rather than the 20 volts that we should be. So now I'm not really sure exactly how crucial that capacitor is, but I don't really want to, I don't want to risk it. So we're going to find out the specifications of that capacitor so that we can use it. But before we do that, I always like to keep the desk relatively clean of stuff, especially since this desk is so small. So I'm going to unplug the thermal cam and put it back around Paul's station. And you can take all this wiring stuff as well. It's interesting because as you saw that it wasn't using enough power when the charger was plugged in by itself. That wire is going to annoy me. Really? Let me just move this thing out the way. Go away. Great, now it's hanging this way. Here, bother Jason's desk. Fucking freaking. There we go. We'll fix that later. So you have a board to fix. Okay. So, PP3V3. Okay, so that capacitor is... That's C3200. C3200 is 10 microfarad, 20%, 6.3 volts. So, yeah, let's see if we could find a 10 microfarad over here on this other donor board. 10 microfarad, 6.3 volts, 0402. That one's 0603. Oh, lame. I need one that's 0402. Oh, give me one that's 0402. Put Pepe in a slot. Here, Pepe can sit here. All right. Hey, 10 microfarad, 0402, 6.3 volts. Let's open a schematic of some retina board that probably will have that on it. Come here, Pepe. You can sit here. Let's see, that's a 4-volt cap. Nope, won't do. Hey. 603, grr. I want a 402. Give me a 402. Aha. C2951 on one of the older retina boards will give me what I need. All right, see. C2951. So I can grab this capacitor from an older retina board. Praise Pepe. You don't measure the old part to confirm. The old part was already measured. The old part was measured when it was burning. That was my first measurement that says that that's not a good part. My second measurement that says that it's not a good part is when I remove it and my short circuit goes away. I had a MacBook Pro like that. LVDS came loose after drop. Best Buy told the lady the motherboard was bad. Best Buy. Does anybody wonder why they lost $480 million a few years ago? Alright, now the issue here is that this chip is underfilled, so don't really want to use a lot of heat next to something that is underfilled. Underfill... Nah. We do this. Where are you going to put my nice shield above that? So I'm going to steal a cap and then place it right there. But you have to be careful when the chips are underfilled. It's interesting because they don't underfill this chip in the 12-inch Retina, but they underfill it on the 13-inch Touch Bar. It's not like the design is a bunch different. Alright. Ah! I'm getting owned like a noob. You're not flying into my air filter. This is noobish soldering right now. That's as crooked as... That's crooked. Did you watch LTT Last WAN show? I saw. Micro Doge, says Fid Fryor. Do you need to be able to read Chinese to work in electronics? Someone asks. I don't think so. Wrong voltage, it's only 6.3. Yeah, but so is this one. Ahem. Let's take a look. C3100, 10 microfarad, 20% ceramics, X5R, 6.3. And I grabbed. All same stuff. So what's going on with this repair, says Jessa? Well, I found a shorted cap, and I knocked it off, and the short went away, and now I'm replacing it. And if you were here, I would have used a wick, but you weren't here, so I didn't. Why would it be a bad idea to use a capacitance meter? It would be a bad idea to use a capacitance meter because it's an entire waste of time. I don't care about the exact capacitance. What I care about is that the capacitor is acting as a wire. So while that capacitor is on the line, let's say this is my voltage, and then you have a capacitor between here and ground. The voltage is going straight through the capacitor to ground. I don't care what the capacitance is because it's not being a capacitor at that point. It's being a wire. So let's draw this in Microsoft Paint. Here, we're going to make a nice little illustration. We're going to do one of my famous illustrations. Find my print screen button. I like that the keyboard I got is so cheap that it doesn't have a Windows key. All right. So this is my capacitor. So, and it's going to ground. Let's get my display going. Display capture. Now let's get rid of thermal cam. All right. So this is my cap, right? And this is ground. So right now, my voltage is doing this. Instead of let's just draw. We're going to draw what's supposed to happen in green, and we're going to draw what did happen in red. So this is what I want to happen. I want my PP3V3 to go through here. Maybe some of it sticks to the capacitor, and the rest of it to go to my chip. Now what's actually happening is that the red, which is what was wrong, but what was happening, is that it's going straight to ground because the capacitor is broken. So this thing, instead of the capacitor being like this, it looks like this in the inside probably because it's broken by the water. So see, right over here, the plates are touching, and that's why I don't care. As soon as I know that the capacitor is sending voltage to ground, who cares? Who cares? It's all here. That's all we need to know. So we replaced it, and we waited for the board to cool off a little bit. So beautiful CD3215 chip that was never underfilled before, but is now underfilled. Thank you, Apple. And we're going to measure and see if we get any difference on the board. I should probably disconnect my power supply wire, but the power supply is off, so that probably isn't going to do anything. I'm going to plug it in, and let's see if we get any fire. So far, there's no fire, which is really, actually, all I could have ever hoped for. So let's see what we get, what voltages we get on different areas of the board now. Now, on the DC in fuse, before we're getting 5 volts, now I want to see if we're getting more. This was the DC in fuse right here. So we went from getting... Hey, is that a... So we had 5 volts before, and now we got 0. Well, that's no fun. Interesting. Interesting and very lame. Okay. So let's see. Let's see if our short circuit was relieved there. 0 volts. Boo. So no fix yet. Now we're going to unplug it and see if there is any type of short circuit. So right here we put that little cap. Nope. So before we had 0 ohms, now we have 1.6 kilo ohms. So there's no short, and the other side is ground like it's supposed to be. Now let's check on the DC in fuse. Interesting, interesting. And let's see on the other fuse on the other side what we get. So 500 ohms. That seems really, really low. Did you knock the small cap off next to C3200? Let's take a look at that. Cap on the left looks burned. Now let's take a look and see what that cap is for, because you guys are right. That does look pretty terrible. Also going to desolder my jumper wires on PP3V3 since it doesn't look like we need that anymore. Just remove those jumpers. Not jumpers, you know what I mean. We don't need this stuff here anymore since... That's the thing. I don't think that this cap over here looks bad. What you're seeing is actually underfill. All of this stuff up here is underfill. So see, I know what you're talking about because it looks dirty. But the cap under that is actually very clean looking, and I'm going to be careful not to damage the capacitor at all right now. But see, the cap under it is actually quite nice looking. Is it short to adjacent capacitor? Doesn't look like it, but let's measure and see. So also, what is the adjacent capacitor for? That's another interesting thing to, another interesting question to ask. Open U. The adjacent cap is a 1 volt, 0.8 volt line. This cap is and those are ground on both sides. So let's see. No, 133 kilo ohms are between those two capacitors, so that's not it. Let's see. Fuse is working. Let's plug you in again. I may just plug it in using the DC in on the other side. Voltage. What's that? Outright 0. That's definitely a downgrade. If we turn this around, let's see if it's the same thing. Sure is. Alright, let's try the other side of the board, and let's also try the other DC charging port. Since there was a red sticker on top of that chip, which means that this was the side that was hit with liquid damage, so maybe I've got an intermittent port. What do you think on Apple slowing old iPhones? Anybody who's been in this business for more than a month knows that they've been doing that for a long time. I mean, the fact that I don't even know what to say. The fact that it's a surprise to other people. If you've been buying Apple phones and you're not used to being told to GTFO or getting laughed at when you have basic issues or needing basic maintenance by now, well, I don't know what world you were living in. So, let's unplug the charger, and let's also take out that charge port. And we're going to try on the other side. All right, so we're going to put that charging port back around where the board was. And first thing I want to do is, after disconnecting the charge port, see if I have any difference in my resistance to ground, and also fix the multimeter, which looked great up until I changed scenes. What is that? 500. Thank you to Levant. Nope, same number. All the pins in this connector look nice. What are your thoughts on the Dell XPS 13? I've never tried it. I did a review of, I think, the 5378. If you Google Dell Inspiron Rossmann Group review, you'll find it. I didn't find enough in the XPSs for it to be worth almost twice their cheaper series. So that connector looks pretty nice. Just gonna plug this in here. Screw it in. Okay, let's screw that port in. These little rubber grommets that come off of their USB-C ports are so aggravating. Okay, so let's plug this in. See if we get any difference with a different port. Zero out of zero. And let's go to the other side of the board. See what we get on that side. I got to get used to this USB-C thing where there's two sides. I'm 5. Okay, we're back where we started. That's cool. 5 volts. All right, whatever. Boring, but let's see. Do we at least get that 3-volt rail that we're supposed to be getting? Yes, I got to get used to that. This is screwing with my head. This is the idea that I have to measure different parts of the board based on where I plug the charger in. That's my fault. I didn't catch that. I got to get used to this. So PP3V3 is 3.4. Okay, so we've got a rail back. We have made progress. This is actually progress, believe it or not. You still have jumper removed? No, I removed the wires for finding the short. That's fine. So as you can see, this rail that was shorted to ground, the PP3V3 underscore G3 hot, is working. So we have made progress. Unfortunately, it's, let's see, is this thing still dead? Yeah, still dead. CPU is cold. And obviously the input to the board is low. PP bus G3 hot is 31.5, 31.6 volts. So we still have quite a ways to go with making this thing work. So this is going to be a project. All right. I'm up for a project. So let's continue onwards and see if we can figure out why this is dead. So to do that, we're going to figure out where the voltage comes. After that comes in, where does it go to? So it looks like we have USB, PP20 volts, USB-C, which is only 5 volts on this one, going to Q3100. And then U3100 is going to open this transistor and allow that through the board and for that to be PP-DC and G3 hot. So let's see if we have PP-DC and G3 hot. So PP-DC and G3 hot would show up over here. It's not SMC, you meme master. So PP-DC in is what it's supposed to be. Hey. Well, not what it's supposed to be. It's stuck at 5 volts instead of going to 20. But I don't want it to be stuck there. I want 20. Well, what do I do next? Let's see. So what do we need to do to get 20 volts? So what's interesting here is it seems like this machine has a different USB-C controller for each side. USB-C port controller B, U3200, which is a CD3215. USB-C port controller A, which is also a CD3215A at U3100. It does lead me to wonder if I were to plug this in on the other side, if I would get 20 volts, because I would be using a different controller that may actually still be functioning. Okay. Yes. So let's figure this out. Replace U3200. That chip is underfilled. That doesn't mean that I can't replace it. I can replace an underfilled chip. It's just it's Saturday night. I mean, I don't want to replace underfilled chips on Saturday night. That sounds like a job for Paul tomorrow, actually. Yeah, if I wind up figuring out that that's what this needs, this is totally going in Paul's status tomorrow. What's up, Paul? What's up, Paul? How do you not panic when it all goes up? Well, I mean, it was dead. It's still dead. There's not really much to panic about here. And part of it is just disconnect and not caring. I really do want to do a good job, but at the end of the day, this is just another circuit board to me. I don't have a personal attachment to it. Okay, so on the fuse on the other side, F. They're still stuck at 5 volts. So that's interesting. Now I'm curious if one of these is bad, does that hurt both of them? That's a good question. Why are we stuck at 5 volts? Why do you never use a capacitance meter in your... Oh, I think we read that already. What did I hit? So, why are we stuck at 5 volts on DC in instead of 20? Why is the USB-C charger not going up to 20 volts? What are our thoughts here? So we fixed one issue. We got our 3.3 back. What else do we got to fix? Well, I suppose what I would follow is wherever the original damage was. So our original damage was over here, right? So this had a red piece on it. That cap was shorted, which means that the original damage was in this area. That's either a RAM chip or a NAND chip. Not sure. But there's nothing nasty looking under there. It's what I would expect. I agree with Jillian on the B&K software. If you press the win button on your keyboard, do you win? Nope. So why don't you want to negotiate all the way up? What I see was on the shorted rail. I just replace it if some of the other voltages are present. U3100, which is actually what talks to the charger here. I'm kind of curious, do I have to replace both? That's a question. So that IC, you have a U30, that IC is over here, but they also have another one over here. Which they call something different entirely, but that's... That's U3100, U3200. Oh, wait, no, it's on the other side of the board. Okay. This side. Duh. I mean, I would actually have to replace both of these because there's two of them. What's this little corroded thing over here? That's probably just a sleep sensor. Let's see. Yeah, hall sensor left. That's a sleep sensor. That's probably not going to be something that's too important since it's not even turning on yet. Then again, would a broken hall sensor cause it to be stuck at 5 volts? No, because it charges at 20 volts, so it wouldn't charge at just 5 volts because you close the machine. So hall sensor, sleep sensor wouldn't do anything. You have 20 volts from the charger. No, we don't. We have 5 volts from the charger. So next question, and I think what's going to be the magic question on these machines, is going to be what conditions need to be met in order for you to get 20 volts from the charger as opposed to 5 volts from the charger. And how do we figure out when those conditions are met? let's see. When we plug it on this side, maybe we get something different. Ah, boo. 5.2 volts. Well, nothing's going to be producing 20 volts if the DC input to the machine is stuck at 5 volts. What we need is for the charger to be told, output 20 volts to me. So let's see where we have lines where the charger would be talking to the machine. We're going to go back to the PDF and just spend some time on that. Put the multimeter aside for the moment. Drink a little bit of water. Get trolled by Jessa a little bit. Okay, so let's go to the charger. So the charging port is going to be J33. Actually, we're going to talk to JB500. Would you recommend the MacBook Pro 2017 to a college student? I wouldn't recommend the MacBook Pro 2017 to my worst enemy. Except, yeah. So this is, let's see, where do you think we're going to have communication going on? The worthwhile communication. So that's where the 20 volts would come in. Boring. I'm looking for something like a bidirectional data line. So here we have USB 2, Thunderbolt, CC1. This sounds like something. I don't know what CC1 means, but it sounds like something that's not USB or Thunderbolt. You know, standard USB or Thunderbolt. It sounds like something that actually has to do with negotiating with the charger. And it seems like that talks directly to this CD3215 chip, which means that all signs so far point to me having to replace the underfilled IC, which is not what I'm doing on Saturday night. There are so many things to do on Saturday night. Replacing underfilled chips is not it. Did you ever want to be an EE, or do you enjoy troubleshooting? Once upon a time. Once upon a time. So it looks like everything comes back to that chip. Let's see, what about all this stuff over here? USB, baud, CC. Yeah, that's going to wind up going to the same place. I'm kind of curious, where does the USB 2 section go to? Imagine that. So the cool thing about the Touch Bar, at least, as opposed to the 12-inch MacBook from 2015, is they don't have the mux everywhere. So when I say everywhere, if you look on a 2015 MacBook, oh my God, that one, this is a mess. Okay, let's find where USB muxing is here in this model. Yeah, look at this. This is a mess. So you have this chip going to this chip, going to this chip, going to this chip, going to this chip, going to that chip for one port. And then that's just for low-speed muxing. Then for high-speed muxing, you have this chip. So, I mean, can you even count the number of chips here? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's crazy. At least in this one, everything is going back to one central chip, which makes troubleshooting easier. But it does mean that I likely have to replace... to do any further troubleshooting, I would have to replace both CD3215As on this board This is what deals with Thunderbolt, USB 3, USB 2, DisplayPort, as well as communicating charging. Actually, well, no, this chip is used 4 times on this board. Wow. So there's 4 of you. Look at this. UB400, UB300, U3100, U3200. There's 4 of you. There's 4 of you, and you're all underfilled. Yeah, about that on Saturday night. So here is where I believe we're going to end the troubleshooting of this today. You may see us come back tomorrow with this, assuming that Paul hasn't quit. But sorry, yeah, it's Saturday night. 4 underfilled BGA chips. Nah. So as always, thank you for watching. By the way, if you do any type of troubleshooting on the 12-inch Retina, yesterday I published a video on the most common flaw with the 12-inch Retina that causes no power. It's a very simple thing to fix. I posted the exact how to diagnose that issue and how to fix it. So do watch that if you do logic board repair, particularly if you're getting 12-inch Retinas that are dead. You're going to see a lot of 2015 12-inch Retinas that are dead because that flaw doesn't need water. It doesn't even need a knockoff charger to be exploited. It's just a chip that just poofs and dies. So I'm out. Pepe is also out. I'm going to find myself some lunch, maybe some dinner in Manhattan while it's still Saturday night before it gets too late. So that's it for today. And as always, I hope you learned something.